Intersection tool in Civil 3D, that's what we are talking about today. We're going to be starting at fairly beginner level and getting to probably a pretty advanced level, so full spectrum of stuff, lots of stuff I want to show you guys today. As always, I like to cram a lot of information into these. So what the intersection tool is for, it's for modeling proposed and design intersections. It's a wizard-based design tool. You put in parameters like width of road and slope of road and things like that, and it creates civil 3D objects like alignments and profiles and so forth. The objects it creates, alignments and profiles, the picture on the right here, it's going to create offset alignments and what are called curve return alignments. It's also going to create associated profiles for those. These are the baselines of the corridor that it's going to create for us. So down here we have a corridor it's going to generate, and that corridor is going to be built off of the alignments and profiles that the intersection tool creates. All these alignments and profiles are based on the two centerline alignments and profiles that we define before we create the intersection. It creates one other object type besides these alignments and profiles and corridors and assemblies. It's an intersection object, and that's actually this little symbol right here. This doesn't have any real model properties to it. It's not part of the surface. It's not part of the corridor. It's a single object that maintains the links between these alignments and profiles. I'll talk more about that as we get into it. So intersection object controls, what it does, this intersection object controls a number of things. The centerline baselines. So when we put in an offset of 12 feet at a slope of a negative 2% to define the edge of the road, that's all based on what's defined in the intersection object. And it's a dynamic link there. So when we say a 35-foot curb return for our intersection, that's all stored. That information is stored in the intersection object, and that intersection object controls those links. What the intersection object also does is define corridor regions and sets corridor targets. So we're going to run through that wizard and define all this stuff, but that's not just a one-time pass-through. Those settings will be saved in this intersection object for us to change them as we see fit and as the design changes. So a little outline, a lot of stuff I want to go through here. I want to go through two examples. The first one is a T intersection with a turn lane. And this is going to be the more beginner to intermediate level, and just make sure you understand how the intersection tool works. It's one of the keys to really being able to harness the intersection tool. So we'll look at the data required to use the intersection tool. We'll start generating alignments and profiles through that intersection wizard. And then we'll look at the dynamic relationships between those and understand how it sets those and controls those. And then, as a second step, we'll actually create the corridor. If you run through that intersection right off the bat, it's and just have it create everything. It does quite a bit. It's a little messy at first, so we're going to separate those into two pieces. I'm also going to quickly touch on making custom assembly sets. What we're going to notice is the assemblies that the intersection tool brings in are not very suitable to most any design out there. So I'm going to show you how you make some of your own assembly sets, and that's one of the things that really makes this tool valuable. We're going to then go to a four-way intersection with some varying widths, and this is where right out of the box the intersection tool gets a little tricky. So the example on the right there, if I've got a 30-foot width of the north-south road and a 40-foot width of the north-south road on the north side, how do you handle that? Right out of the box, you can't put in two different widths for a given crossing road, and so we have to define that with manual alignments. So we'll go through that. We'll also create manual profiles through use of an auxiliary corridor. This is a fairly advanced concept where we define dynamic profiles for use. And then we'll go on and we'll make those intersection alignments and profiles like we did in the first example, and we'll also make the intersection corridor. One question came in, does the intersection tool assure that the vertical alignments match at the intersection? To clarify, the vertical profiles, will they match at the intersection? Absolutely. I'll show you that. We're going to specify a primary road, and that will dictate the elevations through the intersection. So we'll show that in just a moment here. Okay, jumping into Civil 3D. The first example here, like I said, will be this T intersection. And what I have for a starting point here, these red lines are simply just polylines, just giving us a visual of the intersection we're after that we want to create. I also have a few yellow lines. Those are just polylines as well, kind of showing us and guiding us where these transitions for a turn lane and such are. What this represents down here, this is where we're going to end this project. This is going to be left open for future development, so we want to be able to end our corridor right there. So in this area, I have two alignments and two profiles. These are the two crossing alignments. One thing you have to be sure of for the intersection tool to work, if it's a T intersection, that T, that secondary road, needs to come in and match exactly there. If this is crossing it by just even 100th, Civil 3D will get confused and think it's a four-way intersection. So we have a similar scenario down here. That'll be our second example. The profiles we have are some preliminarily designed profiles using the standard Civil 3D profile tools. Don't want to get into that on this webinar. That's not really the focus of today's webinar. So starting off, we're going to create an intersection, and that just starts with the Create Intersection button. So let's go ahead and run that. It prompts us for an intersection point. This is the intersection of the two alignments. It's going to be right there. And it launches the intersection wizard. Okay? Right off the bat, it needs to name this intersection. You can define in your template a name template that actually does this automatically. I'll set that right here. So I can say primary alignment name and secondary alignment name. That's a name template you can set in the command settings of your template. So that automatically populates like that. We're going to get an intersection marker style. That will be that symbol I had shown you right in the middle of the intersection. And also a label style that will label things like crossing, stationing of both alignments. We have primary road crown maintain. In this case, when it's a T intersection, it's going to be the through road that's the primary road in the intersection. Question came in, I see you're using Civil 3D 2016. Yeah, absolutely. I thought I'd show it off to you guys. Can you be sure and mention if there's something that comes into play that's new in 16, different than the intersection wizard in previous versions? Absolutely. There's no change. There's no change in the intersection tool from 16 to 15 to 14. So whatever you guys are on out there, what I'm showing you here today is pretty much the same. Next page here. Some confirmations at the top here of the intersecting alignments. If I had multiple profiles in here, I would be able to select those, but I have just the one finished grade profile. And here's where we define the parameters of our intersection. And so this is fairly intuitive. If I go right into offset parameters here, it opens up another window, and I get primary road and secondary road. And it's interactive and graphic in that when I pick on secondary road, it's highlighted out here. If I pick on primary road, it's highlighted in red out here. So a lot of moving parts in an intersection. There's a lot of kind of graphic highlighting that helps you with that. So right here, what's the width, the offset value of the primary road on the left side? I can pick right in here and type it, or I can use this green box right here and instead do a snap from center line to the perpendicular line right here. Now what is this line? This represents the flange of the curb. So the edge of the pavement. So not the back of curb, not the gutter line or the top face of curb. It's the edge of the flange. So it'll be the edge of the lane subassembly that's created in here. So we've got 15 on both sides. This is not For the turn lane I have here, I'm just specifying the default width of the road here and then on this side. For the secondary road, we have 12 feet wide, so I can just leave that. It's defaulting to 12 right now, so we'll hit OK. And there is the basic horizontal definitions of an intersection. Next option here, curb return parameters. If I click into here, I have two different quadrants. If I hit next, you'll see I get a graphic on both sides here. I have the southwest quadrant and the southeast quadrant. And in this case, on the southeast side, I simply have a radius to define. It's defaulting to 25. If I have my polyline drawn, I'm not quite sure what that is. I can use the green box again. Go snap to this, and the center line, or the center point rather, and that turns out to be 30 feet. Okay, so again, to flange a curve, so if you're defining things based on face of curve, you need to adjust that accordingly, adjust those values accordingly. Now what about the southwest quadrant here? Let's go over here and let's zoom out a little bit. In this case, we have a turn lane. We can define this stuff in the intersection wizard, and it starts by turning on this checkbox. Widen turn lane for incoming road. Incoming road is this side right up here. So I want to turn that on. And then I have some widening parameters down here. So what's the transition type? I get a nice little graphic down here, transition. That's this piece right over here. Curve line curve, and a number of other options. I simply have linear in this case. And transition length, that's the length along the center line of the alignment. So I need to snap right here, and I can snap from there to there, and that gives me 100 feet. The offset value, perhaps I don't remember it. I can come out here, snap from here, and then perpendicular to right here. So it's the offset value, it's the additional lane width for this turn lane. And that, I rounded 1199, I'm going to set it to 12. Then the widening segment length, again it shows me a nice graphic down here. That's the full widening portion, the full turn lane portion. I can pick in here, and I can again snap from here to here. And that is 100 feet as well. So we spell this out in terms of fairly intuitive parameters. I've had a number of people ask me, well, can I define that in terms of how many cars need to be able to stack up there? The answer is no, so you got to do a little math there, but it's fairly intuitive how you put the values in. Lane slope parameters. What is the slope of the two roads coming to this intersection? It's going to default to a -2%, so that's a 2% crown in the road. And I have that for the primary road, and I also have that for the secondary road. Now if I had a cross slope, for example, I'd set one side to +2%, the other side to a -2%. We're going to leave those both at -2% for a typical crown, and we'll go ahead and adjust that after the fact so we can see the difference there. This last set of options here, the curve return profile parameters. These are a little confusing, so I'm going to wait a second and explain these once we get some alignments and profiles created out here. So I've defined my intersection. I go ahead and hit next. And this next and final page of the wizard is the corridor regions option. I can have this create a corridor right now. And in fact, that's what we're really after, right? We want a corridor to be able to generate a surface, to be able to generate cross sections, quantities, all those things that make a corridor worthwhile. For simplicity, we're going to turn this off. So all we're generating right now is some geometry. And these, again, are going to be the alignments that are the baselines in our corridor. But it's a lot to see at once. So I'm going to leave this off it for now, and then we're going to create the corridor in a second. So we see a bunch of white lines now. Also see a label here. This is a standard intersection label that appears. I'm going to push this off to here. Of course, you can adjust that label style. So what do we see here? We see an intersection object. That's this big symbol in the middle here. To me, that's always way too big. Nice little recommendation here. This isn't anything you're going to print, so go into here and make a new layer and call it like no plot and give it a color of some kind of bright off color, and then set the actual layer to no plot. So this is a good thing to do throughout styles in your Civil 3D template, the use of a no plot layer. And when I do that, and also turn this marker down, so it was at 15 feet, a little big for me, set it to 5 feet, and now we get this little symbol there. So those are all template settings you can put in your default Civil 3D template. What else does it create? For each centerline alignment, we get 2 offset alignments. These are offset alignments that are based on the 15-foot widths that we defined. We also get a curb return alignment, and this is based on a fillet of whatever size we defined, and then the 2 offset values we defined for the 2 crossing roads. And over here we can see that we didn't quite get our parameters correct, so we can actually go in and adjust this now. And for those of you who might be used to working with alignments a lot, especially offset alignments, what we don't want to do is just go and pick this and perhaps do some grip editing like this. What this intersection object does is it controls the relationship of all these secondary alignments it made. It controls them and relates them to the centerline alignments. So when you want to change these values, like this curb return, we want to change it through that interface. So I'm going to go and pick on this intersection object. And I've got a number of options up here. I'm going to go through all of them. First one I'm going to go through is this edit curb returns. I get that same window that pops up, and this time it's actually a modeless window, so I can pan and zoom around out here and then see what quadrant. So I'm going to go to the southwest quadrant. What I want to look at is the radius. And again, I don't know what it is. It defaulted to 25, but I can come out here and pick this, snap to there, and the center point, and realize that that should be 30. Notice when I type that in, that alignment basically does a refill it, and it also adjusts the rest of it. So that 100 feet that we defined from here, the end of the transition to right here, that still holds, and the whole thing slides down, matching up with the actual parameters we defined with these polylines. So everything's very dynamic. Other things we can change. Again, picking on this intersection object, this is kind of the puppet master, I like to say, over all the geometry in the intersection. So edit offsets. I go into here, edit offsets. Here's those values again. What if that was 15? That would adjust that 30-foot curb return, and would also slide down that turn lane itself. And it's all dynamic, and again, you pick on these values in here, and it highlights what you're dealing with in the screen, on the screen. So what happens if at any point I go and pick that little object and I delete it because I'm sick of seeing that thing. I don't want that, and I don't know what it is. Don't do that. That is where all the links, the dynamic links that I just showed you, are stored, and that's what maintains those links. So you want to keep that little thing. You don't need to print it probably, so that's why we put the no plot layer in there. Okay, edit curb returns. We had done that. We'd gone in here. This is where we change values. I get all the values for the widening. Everything is in here. The transition. Okay. Again, as you pick on it, it highlights what segment you're dealing with. You can change all this stuff after the fact. In fact, I recommend don't even bother with the corridor at first. Just create these alignments and profiles, and then create the corridor once you have the horizontal geometry in place. The side road profile. This is referring to one of the questions someone had sent in. If I click on side road profile, we didn't see these options when we initially went through the wizard, but they're defaulted in there. So maximum grade of 5% and maximum grade change. What does that refer to? I'm going to go look over at my profiles here. I'm going to go to a couple viewports to demonstrate this. So my primary road, my east-west road, is this profile right here. In the intersection, we're looking at roughly this area right here. And then if in the other viewport I look at the road on the left here, one is called Green Street. I zoom in there. Here's where that profile is tying in at the intersection. So profile locking, absolutely it locks it. In fact, if you click on that secondary road profile, it puts little lock symbols in there, and it also inserts a PVI at the edge of the primary road. So it adjusts these 2 points right here and moves them up and down. So what these values are is, say the secondary road was way off in terms of elevation from the primary road. It would insert multiple PVIs that would extend beyond the intersection such that the grade was never more than 5%. And same thing, it would insert those PVIs based on a maximum grade change of 4%. Those are all good things. We don't want cars bottoming out. That's what that is about. So just to demonstrate, if I make a change to my centerline profile, my primary road, we would expect the secondary road to adjust with it. So if I grab this profile here, turn my O-snaps off, make a change, it's instant. That secondary road profile changes with it. So a great tool there. Let's go back to plan view on the top viewport here. So what else? Let's pick on that intersection object again. What else is this thing linking? The lane slopes, pretty self-explanatory. I can come back in here and I can change these slopes. And then curb return profiles. Here's the one we kind of skipped over in the initial pass-through of the wizard. So what's this about? Let's take a look at that. Pick on my intersection object, go to curb return profiles. And what I get is, again, options for each quadrant. So I'm in the southeast quadrant here. If I go ahead and go to the southwest quadrant, you're going to notice length to extend along outgoing road and length to extend along incoming lane. So right here, this value, if I pick on this, this defines the curb return alignment right here and how far it extends beyond the end of the curve. So the end point of the curve is right there. This is extending 19.82 feet. If you have a whole new subdivision, you can kind of just let these default to whatever they're going to be, and then you model the intersection or areas outside of the intersection after the fact. If it's a case like this, this is where this value comes into play real nicely. So right here, instead of 19.82, I can come in here and snap and say, go only from the end of that curb return to where the end of my project is, which is right there. And when I do that, it's going to put in that default value, or that value of 12.5, and it will also have adjusted that length right there. So why do we care about that? It's these exact endpoints right here, the length along here, that dictates how far that corridor is going to build. So we can use these to dictate where we tie in to the existing road, or where we leave off our project for future development. And that's the case that I proposed in this one here. So that's what curb return profiles are about. It's controlling where that project will end and start. So those are all the adjustments we can make. As I said, go ahead and do that stuff before you've made your corridor at all. When it comes time to make your corridor, pick on the intersection object and click on Recreate Corridor Regions. I know it says Recreate. I haven't created anything yet, but kind of the same difference. Create Corridor Regions. And what we get is that last page that it's showing up in our intersection wizard. I'm going to create a new corridor. I'm going to tell it to target the existing surface. And what this is going to do is it's going to bring in an entire set of assemblies based on this default path right here, C program data, and so on. So I'm going to say recreate, and it's going to build my corridor using all those alignments and profiles to build the corridor. Now right out of the box, the way this thing comes in, the way these assemblies come in, isn't quite what we want. So I'm going to go to a couple of vertical viewports here, and we're going to look at our assemblies on the right. We're going to look at our intersection on the left. And we're going to understand what we have here, and we're also going to fix up those assemblies. So when you run the intersection tool, it brings in a whole stack of assemblies, puts them at the top right of the extents of your drawing. And what comes in out of the box is a basic lane with a curb, and a basic cut fill with a ditch option, daylighting subassembly. What we're going to do is we're going to swap that out for a more basic daylighting subassembly because we don't want to put ditches in behind our curves. So I'm going to go to the generic tab, and I'm going to grab the link slope to surface subassembly. I'm going to set the slope to 10%. I'm going to come out here. Nice little option. We have replace. We can click on replace. This was there in 15 as well. And I can click on replace and it'll swap that out. And it actually maintains the targets as well. Okay, some of these out of the box ones, they don't come in with the curve like you'd expect, so we have to clean those up in a slightly more manual way. So I'll do that again. Go to the left side this time. Again at a 10% slope. So just inserting a basic subassembly here. And we'll replace those left side subassemblies. Okay. And as I said, a few of these we need to delete these out of here and then do a copy to command. So those of you familiar with subassemblies, you're familiar with this command, which is to grab any number of subassemblies and run the copy to command to take subassemblies as they're defined there and copy them up to any other assembly. So that's what we're doing here. When you do this, unfortunately, it won't hold the targets, but that's okay in this case. And the wrong side there, let's do that again. Let's copy from the left side. So as soon as I get these cleaned up, I'll show you what these subassemblies are for, what region they're being used with. All right, so all those assemblies there, just cleaning them up, adjusting the daylight, okay? Now I'm going to explain how these things are used in this corridor. Question came in, can I use the main alignment super elevation to control the assemblies? The answer is no. You define the slope through the intersection based on slopes in that intersection object. So those are going to control in that way. The second option here, where we actually define our own offset alignments, in that case, you would be able to have super elevation control, and so we'll get to that in a second. So I'm going to come over to my corridor, go to corridor properties. Go to parameters, go to set all targets, make sure to reset existing surface for all the daylight surface targets. That will then rebuild my corridor, and I will see a basic scenario like this. All right, let me briefly explain what assemblies are being used here and what the corridor is, what's being created. So if I pick on the corridor and I take advantage of the region highlighting, this region right here uses the assembly we see on the bottom right. It's a full assembly, and it targets those alignments and profiles that are defined in the intersection wizard. So in here, I have the targets assigned for that region. It's those alignments out here that are defined, that are being created. We haven't talked a ton about the profiles. The profiles are just based on centerline alignment in profile, and the width and offset and slope that we defined. So we set at -2% if we're out 15 feet. We're down at a -2%, we're down 3/10 there. Okay, I have that exact same assembly used on the right side here. So it's a full assembly section to define this region. And then have the secondary road. This is a full region here using this full assembly on the right side here. They're pretty much identical unless you define them, change them differently over here. So you might have different curve for the secondary road. We could do that without it affecting the primary road. And then through the intersection, I'm using an assembly like we see on the top on the right there, and that's to define the through road. And it's basically a full assembly with no curb on the right. I then have two curb return regions, and those are using the assembly you see on the right now. And then what they're doing is they're targeting the center line of the secondary road. You can see the outline, the blue outline there. And they're also targeting the offset alignment and profile of the primary road. So this intersection does quite a bit, and not only defines all these offset alignments and curb return alignments and profiles, it also assigns targets to those alignments and profiles and builds baselines in our corridor from those alignments and profiles. It does quite a bit of work for us. So I use the same assembly on both sides. That's what's happening there. I then have one other region in this case, and that's using the assembly you now see on the right to define this region here on the left, highlighted in blue. And that's for the case where you have curb returns that end at different stationings. So because I have that turn line, this region ends at a different centerline station of the secondary road than this curb return does. So there needs to be a little half road region in there. That's what that's about. Okay, so now that we understand the basic structure of it, how do we continue to interface with this? Remember when we were down here and we said, well, we wanted to change the construction limits of it. We don't want to, again, grab our corridor and change this. Because why? Because that corridor region is defined by the intersection object. So again, I can go to my intersection object. If I go to the curb return profiles, it's this value right here, that 12.5, that's dictating that. And so when I run the command update intersection, so I'll show you that now, intersections over on Prospector, and we see it's out of date. When I say update regions and rebuild corridors, so think of this as like the big master rebuild of the intersection and the corridor all at once based on whatever kind of changes I made. When I do this, it's going to basically override whatever kind of corridor changes I made. In that case, we had just made a grip edit there. So I'm going to say update regions and corridor. And when I do that, we're going to notice this corridor region snap back to where it is. So remember when I said the intersection tool is kind of the puppet master? It controls not only all the alignments and profiles, but also the corridor region definitions. So when we say that that region is supposed to be only so long, that information is stored in here and control in there, not in the intersection. It's not that the information isn't there in the intersection, it's just that the control of it comes through the intersection object. So what it means, you try to always interact with regions defined by a corridor, an intersection tool. Try to always interact with those corridor regions through the intersection object. That's the way this works most efficiently. Let's do a couple other things here before we move on to that other example. We can see how that updates. So if I were to come and pick on my intersection object and change this curb return, let's go to edit curb return right here, and we'll change this to 25 feet. You're going to see it kind of get all wacky there. Okay, all we did there was to update the alignment. So now the temptation here is to just rebuild the corridor, but again we have to go back to the intersection and update the regions and rebuild the corridor. So say that, continue with update, and it redefines everything there. So what it's doing, it's not only rebuilding the corridor, it actually shifted some of these station limits of these regions based on that new smaller curve return radius. Okay, I can now pick this intersection. Corridor surfaces, they're just like we've used in corridors. Use my top links in here. I'm going to go to corridor extents for an outer boundary. So nothing new there. I hit OK, and then I build my corridor surface. And I've got contours turned up to a 0.2 foot interval. That's why we see so many contours. All right, let's continue on here. If I get time, I am going to show the custom assembly set thing, but I do want to make sure to get through this other intersection. So given the time, I'm going to move on, and we'll touch on the assembly set at the end if necessary. All right, a different intersection. How do we handle this? If you remember, we went through the intersection wizard, and we could only specify one width. We can't do one for each side of the road, but only one width in total. Question came in on the southwest corner at the westerly PC. Let's go to the southwest corner. On the westerly PC, that would be this point right here. Is there a overlap in corridors? There is no overlap in corridor. Let's see. Let me clarify. There's overlap in alignments. And if I pick, oh, I think I see what you're talking about. That small link right there. That's actually not a link overlap. That's a corridor feature line connecting back to a different corridor region. So we have one region here and another region there. That is connecting the edge of travel way feature lines across there. So that's not an actual overlap. And we know there's no overlap of regions because when I highlight these regions in blue, we don't see any overlap. The alignments, however, they will overlap, and that's just the way the intersection builds them. So let's go back here. To make this work, you have to define separate offset alignments. You have to define those manually. So let's go ahead and run through this. Take my centerline alignment and make offset alignments. So I'm not going to talk about these tools in detail, but I'm going to make offset alignments of 15 feet on both sides. These are great because they're tied horizontally to the center line. To manage this widening, I can go pick on that offset alignment and do add widening. And this allows me to put in a widening to go from right here to the end station. And now what the widening is going to be from center line. So if it's 40 feet wide, my total width here should be 20 feet on one side. And what I get here now is a widening in my offset alignment. So the transition, I don't want curves in there. I simply want a linear transition. So I change that over there. And then I can come down to this offset alignment, and you get this goofy little gray grip here. If I pick on this, what happens is other grips show up at the end of the transitions. I can then grab these and adjust those to the appropriate transition there. So I'll do that on both sides. Add the widening. We're going to go from right there up to here. We're going to go 20 feet wide. Now it puts that 20 foot in there. The transition isn't quite what we want. Again, we want it to be linear, and we want to adjust the transition. Okay, so that's how we have to define this. Secondly, we need profiles. The corridor tool will not build profiles for us. But what do these profiles need to look like? Well, right out here, they need to be just 2% down from center line. So I'm going to employ a different strategy here. I taught it in some other classes recently. It's the use of auxiliary corridors. And I taught this in another webinar too, so I'm going to kind of go through this quickly, not explain it in detail. Again, you can go check out another webinar. But what we're going to use is a setup corridor. So to make a corridor, I first need a different assembly. I'm going to call this a setup assembly. I'm going to put this over here, and all we're going to attach to this thing are two very basic link width and slope sub-assemblies. I'm going to go 25 feet wide at a negative 2%. Attach that to the left side. I'm also going to put one on the right side. Okay. I'm now going to build a very basic corridor out of this north-south road here. So I'm going to go pick corridor. I'm going to call this the setup corridor. The alignment is going to be Purple Street. That's the north-south road here. And then we're going to go the finished grade profile of that, and the assembly will be the setup assembly. And all we're doing is making this corridor that just runs straight through here. Next thing I'm going to do is build a corridor surface out of this, out of top links. And there's that corridor surface. Now that we have a corridor surface, we can cut a surface profile. We'll cut profiles using these offset alignments. Okay, so now that we know that the corridor is in place, it's a very basic corridor, and surface just represents a 2% crown extending beyond the limits of our road. Okay, so, but I know that I can cut a profile anywhere along that and know that it'll be down 2% from the center line. So I'm going to go ahead and turn those off for the moment. I'm going to start with my left offset alignment. I'm going to do a surface profile. I'm going to cut a surface profile of the setup surface, add that to the list. And I'm not even going to make a profile view, because I don't even really need to see that. That's just data that's linked to centerline. So hit OK. Now we have a surface profile for the left. I'm going to do the same for the right side. Surface profile, setup surface, add that to the list, and hit OK. Okay, now I have profiles for both of those. That's the data I'm going to use to define the width of Purple Street, the north-south road. So once that's in place, I can now go into the Create Intersection tool. Again, it prompts me to select intersection point. I'll pick this right here. And then, because it's a four-way intersection, it says select main road. That will be the left, right, or 12th Avenue road. Again, these same options. This time, though, we're going to do all crowns maintained, so we won't maintain primary road crown through there. So we'll see that blend in that way. The offset parameters, let's jump into here. So the offset parameters for the primary road, that's the east-west road, that's still 15 feet. Now here's the other option we're going to use here. Use an existing alignment for the secondary road. We're going to say yes, and I'm going to go out here, pick my alignment name, and that's going to be this offset alignment right here. I'm also going to do the same for the right side of the road. So here's where the intersection tool becomes a lot more flexible. These are some of the reasons I see a lot of people trying to use the intersection tool say, well, it doesn't work for me because I have this, that, or the other thing. There's, of course, a lot of scenarios. I'm only able to show you one here, but this is one of them, a common one. Curb return parameters. I'm going to leave these as default. They're all 25 feet for each curb return. I'm going to go into lane slope parameters. Now here's where those surface profiles from our auxiliary corridor come into play. I'm leaving it as default 2% crown for the primary road, the east-west road. But now for the profile, I have to say yes, and I have to go out and grab, see if I can find it in my list here, my setup surface. I just happen to know by the count there. I could have renamed these, but 6 is the one I did first, which is on the left. So I'm going to pick that one. I'm going to do the same for the right side. So this is dictating the edge of travelway, or the edge of pavement of the north-south road. Okay. If you don't set those, it's the Civil3D is going to bark at you and say, look, for user-defined alignments, you need user-defined profiles as well. Curb return profiles, we're going to let that default as well. Hit next. I'm going to create corridors in this intersection area, and I'm going to add it to an existing corridor. That's the one I have already. So when you're building multiple intersections, put them in the same corridor. That doesn't mean you put 20 intersections in the same corridor. If you have that much, you need to start breaking it into multiple drawings. A site this big, everything in one corridor. So I might go up to perhaps 4 to 6 intersections in one corridor drawing, in which case we'd put all the other corridor work between those intersections in there. Okay, we're going to add that to the same corridor. This is going to be a different intersection, so it's actually going to bring in a couple different assemblies because it builds slightly differently. So I'm going to go ahead and do create intersection, and at this time it's going to make not only the alignments but also the profiles. So it crunches away there, and there it builds that intersection. We see those assemblies come in here. Let's go and just update those a bit. Again, they come in with those wrong daylight subassemblies, so I'm going to delete those and put in a fairly simple example. Copying the curb and the daylighting subassembly, putting those up here. So granted, we would have potentially sidewalks and a number of other things. If it was a reconstruction, we'd be trying to tie in around right-of-way, a whole lot of other considerations behind the back of curb here, but not the focus of this webinar. I can now come to this corridor, select corridor properties, go to my parameters and set all targets and make sure existing is set for all those daylight subassemblies again. And I can rebuild that. And now that updates accordingly. Okay. So this is what I recommend. When you build multiple intersections, first build the intersections, and then go and grab your corridor, and you could do a copy region, copy this region, and fill in the area in between. Okay. Something you'll notice right away, the width of the road is different. Okay. The width of the road out here is based on the default width of the assembly. So you certainly have to change the lane subassemblies to 15 feet. That was just defaulting to 12. We need to set it to 15. So in the intersection areas, none of these default widths or slopes make a difference because everything's controlled by targets. When it comes to regions outside of it, then you have to look at the default values in the assemblies. So if I rebuild that corridor now, that'll adjust to the proper width. I can also edit the frequency, set it to perhaps 25 feet so we don't have so much detail. I do have a couple other questions coming in. I'm going to hold off on them for right now. I will address them through email or phone conversation as necessary after the fact. So what we can see though, this intersection built, if I go and grab this surface, it's going to be the simplest way to look at it in 3D. Grab just that surface. I think I grabbed the corridor as well. So now we get that widening change in here. 20 feet wide down, or 30 feet wide down here, 40 feet wide down here. A whole other bunch of scenarios we could consider. There's a jog in the crossing road here. Okay, we would want to define that certainly in our centerline alignment, but we'd also need to define it with our offset alignments. We could have done the same for the primary road. We could have defined those offset alignments. The great thing this does still is that even though we manually defined the offset profiles here and alignments, what it does for the profiles along the curb returns is those are still linked. So let me do one little thing here. Let's say we want to put a catch basin in here. So here's this curve return alignment. If I pick this guy and I go to Profile View, I can now view this thing in a profile. So the data was there before, but we just weren't seeing it. So if I drop this over to the left side here, here's that profile. And if I pick on it, I actually get a few little grips that show up. So these little diamond grips that we see here, those correspond to the PC and the PT along here. So we actually have full control of the profile in that area. So I can pick on this, edit profile geometry, and I can put in a low point or a high point, whatever I have to do to control drainage around that curve return, I can place that in there. Okay, so that area again is not controlled by the intersection object. All the intersection object does is set this based on width and slope from center line, width and slope from center line here from the two roads, and then it just connects the dots between, so you can adjust that space in between as you see fit. So if I come over to the intersection now and rebuild it, I made it pretty drastic there, but you see those contours now coming down in there. Get this label out of here. Okay, so you have a lot of control along those curve returns. All right, that's most of what I wanted to show you today. I'm not going to be able to get to those assembly sets. Actually, yes, I will. I'm going to show you right now. Time me, see how long it takes. All those assemblies that come through, they come in, they were kind of messy, a lot of stuff to deal with, right? Well, we go to C Program Data, we go to Autodesk, we go to C3D 2016, we go to NU, we go to Assemblies, big long path, you see it up there, C Program Data, blah, 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 Imperial. This is where it's pulling from. This is the default location it's pulling from. If you want to make your own, go grab this entire set, make a copy of it, and put it someplace else, like your desktop. Okay, not really your desktop, but put it on your network somewhere for everyone to use. So make a folder, CTC assembly sets. I had one here already. Let me delete this out of here. So you make an empty folder and then go and paste everything you copied from the default. This XML is kind of what's controlling everything being used in here. So take this and rename this thing. Call it CTC assembly sets. Okay. Then we take this path right here. I'm going to make a copy of this. And I'm going to go into this XML and edit this in Notepad Editor. And all we need to do is make edits to the paths in here. So if I dive in here, there's a path. It's shoot. Sorry for the confusion on this. I got to turn around a little bit. This is the path you want to be changing in here. CTC assembly set. So it's in here actually 29 times. You're going to have a default one in there that Civil 3D puts in there. You just want to come into the XML file and do a find replace on that and put in the path that you're putting all this stuff on your network in. So you change it in the XML. The XML is what people browse to in the intersection wizard, and then you just manually open each one of these drawings in Civil 3D, and each one of those is an assembly, and you just change those to your liking. So what it means is, do you have gravel roads? Do you have paved roads? Do you have concrete? Do you have asphalt? Potentially. So make multiple assembly sets for all those different scenarios. Is it rural? Is it urban? You have curb and sidewalk, or do you have shoulders and ditches? All that stuff can be handled in here. You just need to make different assembly sets. And then when those assemblies come to the drawing, everything's set to go. All right, a few more points I'd like to make here. Does this really work? Well, it worked today, right? But you might be saying, well, my projects, I have this, that, and the other thing. Absolutely, a lot of scenarios. So when does it work? It works when there are enough typical parameters, like slope, like offset, things like that, that you can define them through an interface in the software. And even then, when you can't, and you just have some things like a change in width of the road, you can define them through offset alignments and use tools like setup corridors to really automate the definition of those profiles. What really makes this all possible is that you really understand what the tool is doing. This is the number one thing I see with people who have a hard time with the intersection tool and who then conclude, I can't use the intersection tool. You have to understand all the targets, all the baselines, all the regions and alignments and profiles that it's creating so that you can step back and say, well, in this road recon, we have to tie in over here. How do I handle that? If you know how the intersection tool is thinking, you'll be able to manage that. So when will it not work? It's when there's almost no typical parameters, meaning you're manually designing the intersection completely. You have no typical slopes coming into it, no crown, no cross slope of any standard, no width of any standard. That's when you end up having to make all those alignments and profiles manually anyway, and at some point it starts to not quite be worth it. It would still set all those baselines and regions and targets for you, but it ends up being a little more tedious. So a couple other alternate uses I wanted to mention. I see people using it just to link the centerline profiles. When I was in that intersection wizard, I could have chosen not to make any offset alignments and profiles, and I could have just linked the centerline profiles. That alone, if you have to build your intersection manually, that alone is a nice little advantage. Or you could use it for a starting point for a design to get you kind of in the ballpark. And then as soon as you delete that intersection object, that little bullseye thing that was in the middle there, as soon as you delete that, those become a whole bunch of independent alignments and profiles that you can tweak to your liking. So a lot of options there. It's hands down one of the most powerful tools in the software. You should really try to figure out how you can make it work for you.